Hey everybody, this is Miss Dupe, and today we are going to talk about the negative exponent rule. So the negative exponent rule says when we have a negative exponent, we flip that base and the exponent to either the numerator or denominator of the fraction, which, just a reminder, the numerator is the top and the denominator is the bottom. So some examples we have at the top, we had 2 to the negative 1. We flipped the 2 to the negative 1 to the bottom of the fraction and made it 2 to the positive 1, and then we put a 1 on the top. So that's kind of a visual of how that works. So the first example, we're going to do the same thing. So 4 to the negative 6th power. We want to make that exponent positive, so we are going to put a 1 on the bottom, make it a fraction. There's always an invisible 1 on the bottom of a number that's not a fraction. So now we're going to flip this to make it 1 over 4 to the positive 6th power. The next one is the same idea. We have x to the negative 2nd power. We want to make that exponent positive. So we put a 1 on the bottom to make it a fraction. We flip the x to the negative 1 and the 1, or x to the negative 2, sorry. And then we put a 1 on the top, x to the positive 2 on the bottom. So as you can see, the goal of this is to always end up with a positive exponent instead of a negative 1. So this next one, we have the opposite situation. We have a 1 on the top, and then we have 10 to the negative 1st on the bottom. We are still going to flip this, just things are going to go in the opposite place. So we're going to have a 10 to the positive 1st up top. And you can write over 1. But now we have that kind of invisible math rule, so we actually don't really need to write the 1 on the bottom. We're just going to have 10 to the positive 1st. Number 4, same thing. We have a 1 on the top and an r to the negative 5th on the bottom. We're going to flip this fraction so that r turns positive when we bring it to the top. And then we really have a 1 on the bottom. We're just going to let it be an invisible 1 on the bottom. For number 5, this is when we start getting into using multiple rules at the same time. So this is product rule, which means we are going to add the exponents. So I would highly recommend doing this in your calculator, just because a lot of us are not super confident on adding, subtracting, multiplying, and dividing with positives and negatives. Now we know with product rule, those base 7s are going to combine to be one big base 7. And we also know that we're going to add those exponents, like I said. So we have negative 2 plus negative 9. And we are going to add those to get a negative 11. Now this one is going to kind of be done in multiple steps because we still have a negative exponent and we want to make it positive. So now is the part where we're going to put a 1 on the bottom. We're going to flip this fraction, and we are going to have a 1 on the top and 7 to the positive 11 on the bottom in the denominator. So number 6, we're also doing the product rule again, so we're going to add the exponents. So we know those k's are going to combine to make one base k. And then we're going to add 9 plus negative 12. So like I said, would highly recommend you doing that in your calculator. That's going to end up being negative 3. And then in order to get that exponent positive, we're going to put our invisible 1 on the bottom, flip the fraction, and have a 1 on the top and k to the positive 3rd on the bottom. Now, as you can see, number 7, 8, and 9, we all have the quotient rule. So the quotient rule says that we subtract the exponents. So now we are going to combine our base 8s to be one big base 8, and then we always do the exponent on top minus the exponent on the bottom, so 1 minus 10, which that is -9. Once again, don't be shy about putting this in your calculator. So now we're going to put our invisible 1 on the bottom, flip this fraction, and we get 1 over 8 to the positive 9th power. This next one also quotient rules, so we're going to subtract the exponents here as well. So we're going to combine those base b's to make one big base b, and then we're going to do -7 minus 7, which makes -14. We put our invisible 1 on the bottom, we flip, and we end up with 1 over b to the positive 14th. This last problem that I have on here, but I'm going to show you a few more, is also quotient rule. So we're going to subtract the exponents again. So we have a big base 6, and we are going to subtract -3 minus -4. Please do this in your calculator, but I'm going to show you this off to the side really quick. Before in math we did -3 minus -4. And two negatives make a big positive. So this is really -3 plus 4, which gets you a positive 1. So this is really 6 to the positive first power. Since we end up with a positive exponent, we actually don't even have to do anything with this. So this answer ended up being positive instead of negative, and we didn't have to flip anything. The last couple problems we're going to do are ones that are a little bit more complicated and have a few more variables and different things going on. So in this problem, the only thing that is the problem are the negative exponents. So I'm going to highlight for you where our negative exponents are. Here we have x to the -5th, we need to fix that, and then we have z to the -2nd, we need to fix that. The other two things are coefficient of -2 and y to the positive 3rd. Those things are perfectly fine and can stay where they are. So we are going to start rewriting this problem. First, we're going to keep the -2 where it is. We are also going to keep y to the 3rd where it is. I'm going to draw the fraction bar. Now, x to the -5th actually needs to go to the bottom of the fraction so that it becomes a positive exponent. So by moving x to the -5th to the bottom, it's now going to be x to the positive 5th. The opposite way, z to the -2nd, needs to become a positive exponent, so we're going to move that up to the top to make it a positive exponent. So now on top we'll have a z to the positive 2nd. Since none of these bases match and -2 can't multiply or divide with anything, this is our final answer for this one. This last problem we're going to do is 4a to the -4th over 6b to the -2nd. So there's quite a few things that we need to do in this problem. The first thing we need to do is actually deal with our coefficients. We see we have 4 over 6, which can actually reduce. It doesn't divide, but it reduces. So in your calculator, you need to type in, I'm going to write this at the bottom, 4, and then hit that A, B, C button, and then 6, and reduce that fraction. I'm doing it right now. So when you reduce that fraction, you get 2/3. So now we're going to start out our answer for this as 2 over 3. And we're going to leave a lot of room on that fraction bar because we still have a to the -4th and b to the -2nd to deal with. So these two things are actually also issues that we need to fix. So first of all, a to the negative fourth needs to go to the bottom because it's a negative exponent and needs to become positive. So we're going to move that a to the negative fourth to the bottom to make it a to the positive fourth. Then we are going to do the same thing with b to the negative second, except we're going to move it up to the top. So we move b to the negative second up to the top, and we make it b to the positive second. And that is actually it for that example. So I hope you now understand our exponent rules, and let us know if